This is a problem of geometry. Here a quadrilateral is obtained by joining the midpoints of a rectangle. When we join midpoints of a rectangle, we get a rhombus. If the area of rectangle is x, then area of rhombus will be 1 by 2 of x, and when we join midpoints of this formed rhombus, we'll get a rectangle, and area of this rectangle will be half of the area of rhombus. Therefore the area of second rectangle will be x by 4, and again when we join this rectangle will get rhombus, area of which again will be half of the interior rectangle, that is x by 8. Now the sum of the area of rectangles will be x by x plus x by 4 plus x by 16 and so on. This will be equal to 4 by 3x using sum of ZP. Similarly, the sum of second sequence, this is 1 by 2x plus 1 by 8x plus and so on, will comes out as 2 by 3x. Therefore the required ratio will be 4 upon 3x is to 2 by 3x, which is nothing but 2:1. Now one thing could be noted here, we did not need to compute sum of areas of rectangles and rhombus, as the area of first rhombus is half of the area of original rectangle, and this same pattern continues till infinite, which means the sum of areas of rectangle in that situation will be twice the sum of areas of rhombus. So just by observing this, we could have reached to answer instead of computing their sum using formula of sum of ZP. So that's all.